When talking about data, we often hear the terms data structure and abstract data type. So let's actually talk about what the differences are between these two. Data structures are collections that contain data values, the relationships among the data, and the operations that are applied to the data. Importantly, a data structure describes exactly how the data are organized and exactly how the tasks are performed. So a data structure actually defines every single detail about anything related to the data. Whereas an abstract data type, on the other hand, it's defined by its behavior from the point of view of a user. So not exactly how the operations are done, but just what operations must it have from a completely abstract point of view. So regardless of how it does those tasks, just what operations must it have. So specifically, it describes only what needs to be done, not how it's done. It has no details about how any of these operations are performed, just what operations need to be performed. Let's take a look at an example that should hopefully be familiar to you. You've probably seen the Arraylist data structure in your prior data structures courses, but it turns out that the Arraylist data structure implements the list abstract data type, or ADT. What exactly is a list? Well, I know that a list should be able to add elements. So I, as the user, should be able to add a new element to a given list. I should also be able to find. If I have an element of interest, I should be able to ask, does this element exist in my list? And the list should be able to tell me, yes, it does, or no, it doesn't. And I should also be able to access a specific item in my list. So maybe I want to see what is the third item in my list. I should be able to find it. I should be able to remove elements from my list. I should be able to say, I want to remove this specific element from my list. I should be able to get the size of my list. So how many elements currently exist in my list? And importantly, my list should be ordered. There should be a first element, a second element, a third element, etc. Let's imagine a scenario where I have some empty list. Let's say this list will contain strings. I can add a string, for example, the word fast, and now my list has one element where the first element, the only element, is the word fast. I can then add a second element, maybe the word and now my list has two elements, first fast, and then and. I can add a third element, the word furious. So now my list has three elements. The first element is fast, the second element is and, the third element is furious. If I wanted to, I could say remove and then I would delete the word and from my list. Now I have two remaining elements. First is fast, second is furious. How does this relate to the Arraylist data structure? Well, recall that an Arraylist should have some backing array of some sort. In this example, let's say it has 4 elements, or 4 slots. And it should also have some form of a count, keeping track of how many items have been added to this array list. Initially, this count will be 0. I add the first word, fast, and this should create a string object representing the word fast, and the first slot of my array should be a pointer to that object. And now my count is 1. I can then add a second word, maybe the word and then now a new object storing the word and will be created, and the second slot of my array will be a pointer to this new word. And now I have 2 words. Similarly, I'll add the word furious. Now the third slot is a pointer to the word furious. I have 3 items. If I want to see what's the size of my array list, I can just return this count. If I want to find an element, I can start at the beginning and search for it. And similarly, if I want to remove an element, for example, the word and, I could do different things. One simple option could be to just delete this pointer and decrement this count, and somehow keep track of this being a dead slot, or I could shift over all the remaining elements. Regardless, I can have some specific implementation of how to remove an element. So the key takeaway here is that the list abstract data type did not define how any of these operations were performed. All it said was a list should be able to do this, should be able to do this, etc. It just said what needs to be able to be done without defining implementation details. A data structure, on the other hand, actually defines how the data are organized, how the different operations are performed, and how exactly everything is represented.